Hello and welcome to Cave to the Cross Apologetics. I'm Tony,
I'm Patrick.
and we are working our way through J.P. Moreland's book, Scientism and Secularism, Learning to Respond to a Dangerous Ideology. And we just finished up in our last episode, chapter 7, where he takes to task weak scientism. We already saw how he dealt with strong scientism, and basically says they have the similar problems, right, with regard to the basic assumptions that they fail to recognize because those assumptions are philosophical and not scientism or not science that holds up the scientific endeavor. So that was chapter 6 on weak scientism. And this time we're going to move to chapter 7. So chapter 7 talks about the availability of non-scientific knowledge, right? So notice what he's going to claim here is that while scientism claims that knowledge only comes from science, he's going to suggest, no, that's not the case. There are other sources of knowledge that aren't scientific. And if that's the case, then clearly the claims of scientism are false. And so that's what he's going to walk us through in this chapter 7. All right, and he says scientism claims that it has cognitive superiority over all other fields of knowledge and study. So he asked the question, but what if there are things that we can know with greater certainty, right? And in different ways than we know the claims of the hard sciences. And so in this chapter, as I mentioned, he wants to briefly think with us about 3 kinds of claims: logic and math, our personal conscious states, and the moral law, right, to show us that the emperor of scientism has truly no clothes. And so that's what he wants us to see in this particular chapter.
Right. So we'll get a little bit more heady here in chapter 7. All right. Well, what about this whole logic and math thing? We can know this better than we can know science? Well, he's already mentioned the importance of the laws of logic and of the basics of mathematics. But what is it about these areas of knowledge that set them above science? They have 2 characteristics that are worth noting. First, the law of logic and basic mathematics are known in an a priori manner, by direct rational institution or awareness, without appealing to sense experience to justify them, right? So again, how is this table in front of me made up of? Well, of wood and plastic. Okay, well, what are those? Well, I have to develop tools to disassemble and to break down these parts into even smaller components, and then I have to see what their structure style is, and then I find just a bunch of empty space, but within that empty space I find these little small particles, and I'm going to label them, and then what are they made up of? Well, then I have to build a big little slingshot around pretty much all of China, and then we'll maybe be able to see what those things are made of.
Or even worse, the table is just a hologram.
Right.
And so notice our cognitive or our sense perception sees a table, but it's really a hologram. And so but we think it's a table. But we can't make a mistake about 2 + 2 = 4.
Right.
It's 4, right? So there's no hologram, right? There's no confusion. There's no, oops, I made a mistake by my experience, right, or perception. And so that's the point that he's trying to make here, right?
Right.
Mathematics, laws of logic are a priori, and we know them by direct rational intuition or awareness. And that seems to be, he's going to argue, superior to sense perception.
Right. We can just rationally see that they're basic laws of logic and math and they're true. Then we can move on. That's it. That's all you have to do. That's how easy math is. For those people that claim that they're not math people, it's just the basic underpinnings of all reality for you.
And so he goes on to say that by contrast, then the theories and laws of science are, in one way or another, known in an a posteriori fashion. Right? That's the kind of what we were getting at there, right? By our sense experience, eventually requiring an appeal to our observation and our sensual perceptions and that sort of thing. And so for any set of observational data, there's always more than one law or theory consistent with those data. And so he's getting at here what the philosophers of science call the underdetermination of theory by data, right? In other words, your observation of something, you make a theory about it, a scientific theory, right? But you can have a number of scientific theories that meet that same observation, right? And so for any set of observational data, right, we make an observation. He says there is always more than one law or theory consistent with that data. So we see something happen, but there are multiple explanations. even scientific explanations, right? And so he says it's generally, though not universally agreed, that greater rational certainty is available for a priori truths than for a posteriori truths. And so that's the first point he wants to make. This distinction between a priori, right, where we know by rational intuition something is the case, versus a posteriori, where we know by our sense perceptions. And in general, right, most folks would agree that the rational certainty of a priori truths are greater than a posteriori truths. And yet science is based mostly with regard to observational data on a posteriori truths.
Right.
And so math and logic seem to be superior, we might say, and give us knowledge over and above science.
Maybe that's just a difference. Maybe they're just slightly ahead in that area. Well, he's going to actually give us a second one. So the second characteristic of truth in logic and mathematics is that they are true. They are necessary truths. It's impossible for them to be false. Wow, okay, that's pretty impressive. But by contrast, scientific truths are contingent. Even if a scientific principle is true, it could have been false. And again, my shelves over my shoulder are strewn with a litany of sci-fi books that postulate, well, what if this was the case? And, what if science doesn't quite work like that when we're exposed to really fast speeds or really high gravity, or what, we go back in time and it quite wasn't like that. So it could have been something that it isn't. But something like 2 + 2 is always going to be 4. It always has to be 4. It's always impossible for it to be anything other than 4. So if it's possible, for example, to imagine a world with different laws of nature, then we're unable to get there. And again, with even in the comic book world, there still has to be, you as the reader have to draw some inference to it. There has to be a way for you to relate to it. And you might be able to believe that Superman can fly, but if he's doing math that doesn't comport with what your understanding of as something as simple as 2 + 2 = 4, then you have no frame of reference at any point in time there, and that world doesn't operate well. So flying Superman, good. Clark Kent making a mistake on the blackboard for a math test, entirely possible. Right.
Yeah. All right. So that's the second one. So first, this distinction between a priori and a posteriori, gaining some knowledge. And then secondly, the distinction between necessary truths and truths that are contingent. And logic and math give us necessary truths. It's impossible for them to be false. Whereas scientific truths, since they're based on nature and our observations, which can change, right, are contingent. And that means that they didn't have to be the way that they are. So that's one non-scientific source of knowledge, actually two, right? Mathematics and logic that are not scientific. What about another one? Well, the second one he gives us is our own personal conscious states, right? So what's he talking about here? Well, it says, in addition to the laws of logic and math, we have greater rational authority about what is happening, notice, inside our own conscious lives than any other person does, right? So I know more of what's going on inside of my conscious life than anyone else, and vice versa for every other individual. And so he says, how do we know our own conscious states? Notice, not by any scientific empirical means, but by direct introspection. Right? So we don't do a scientific experiment to know what I'm thinking, right? Let me see. I have a headache. Let me do a scientific experiment to make sure. Well, no. We know that by direct introspection. We know that more thoroughly than we know any scientific claim, quite frankly, right? And so he says, assume for a moment that he's focusing on his inner life and he's not daydreaming. All right. So he says, in this state, I'm in a position to know what is happening in my own mental life with greater epistemic certainty than other people have in knowing what is in my conscious life. And so, a neuroscientist could know with greater certainty what's happening in his brain, how the neurons are firing and the chemicals are moving from one, the synapses to another and so forth. But he cannot know with greater certainty what is going on in my mind. Right? What my, particular introspection, conscious life is all about. And so we have our own personal conscious states that are superior to scientific knowledge. They give us knowledge outside of scientific knowledge.
Right. So the neuroscientist can tell you that you're feeling sad because the chemicals in your your brain are low, but they can't tell you why you're sad, or that the way out from being sad will release those endorphins and fluctuate your mind better. They can unnaturally, medicate you to do that. But what's going on in your mind that is affecting your brain is not quite there. I do remember one of our early intro to philosophy classes. I think we spent probably more time than the professor wanted talking about whether or not we knew we had a headache. And I thought that was a fascinating moment of I really want to study philosophy. So I distinctly remember that lecture a little bit more than we probably gave our professor a headache as well. So although we wouldn't know, well, only he knows, so he'd have to tell us. Well, one might think that the day will come in which scientists have so precisely correlated mental and brain states that a scientist could indeed know better than I what's going on in my mental life by simply reading my brain states. But this is not true. Why? Well, in order for a scientist to develop a detailed chart correlating specific mental and physical states, well, he must ask the experimental subject what is going on inside of them as he reads the brain monitor. Thus, any correlation chart will be epistemically dependent on and weaker than a subject's own introspective knowledge of his conscious states, because the chart is dependent upon the accuracy of the experimental subject's reports of their own consciousness. And it reminds me of a Simpsons episode where Homer's brother renews his wealth by getting Maggie to talk using a machine. And so I've always wondered, is that entirely possible? But that might be true for, a Maggie Simpson, I'm hungry, I'm cold, I'm wet. But is that true for everyone? Did it sell because it actually told the truth about what a baby was actually thinking? Well, it doesn't seem so, because that's only one subject, right? So it always goes back to The Simpsons for me for this one.
So they explain everything.
Yes, exactly.
He says a related matter is that consciousness exhibits private access. And so he tells us to take any physical entity whatsoever, a rock, an organic chemical, or a state of the brain. Any way you have of knowing things about the physical entity, size, shape, mass, is also available to me. So the same way you can know about it, how big it is, the shape of it, the mass, whatever, that's available to me. But he says that we have a way of knowing about our own conscious states that is not available to other people, direct introspection. And so these facts are privately accessible only to the individual. So he says, if all of this is so, then, we have a greater epistemic authority for knowledge of our own conscious states than we could ever have of the laws of nature and science.
Right. You're lying, and I know you're lying. Well, you may be able to know one of those things, but you don't know if you know both of those things. All right. Well, how about the path of moral knowledge? Well, let's consider the following item of moral knowledge. It is wrong to torture babies for the fun of it. We put that statement out there. I'm sure no one on X will even remotely, or Blue Sky will be able to claim that's not the case. So it's all something that we can agree on, right? Hopefully. If someone claims he doesn't know that is true, he needs therapy. And not an argument. It is self-evidently and intuitively obvious. It is possible to imagine that if 50 or 100 years from now, most people will no longer believe this truth, but it's hard to see what evidence, arguments, or other rational considerations could be discovered in that time frame that would make it completely irrational belief to hold.
Exactly. And so he compares this with, beliefs about electrons. He says, is the same thing true of beliefs about electron? And he says, not at all, as the history of our understanding of the electron demonstrates. And he gives us some, kind of a history lesson here, a real brief one, right? He says, consider the different views on electrons held by J.J. Thomson in the early 1900s and Niels Bohr's during the same period, and versus contemporary quantum physics. He says Thomson, an English physicist who won the Nobel Prize in Physics and is credited with discovering and identifying the electron, so that's a big deal, right? Held that electrons were, notice this, non-orbiting, negatively charged particles embedded in an atom, much like raisins are embedded in plum pudding, right? So the plum pudding theory of electron is what we got from J.J. Thomson.
So obviously we can't argue with the guy that discovered it, but where would we be without scientists who disagree with each other? Well, Niels Bohr, a Danish physicist who also won the Nobel Prize in Physics and made important observations about quantum theory and atomic structure, he disagreed. I disagree with Mr. Thomson over here, probably Dr. Thomson. Rather than viewing electrons as non-orbiting, he argued that they do orbit, but only in discrete, specific circular orbitals at specific energy levels. And if you've taken your classes in chemistry, boy, you know those models. So you probably know where this is going. Well, the current model of the electron is part of the modern quantum theory. And one interesting feature of current quantum theory is whether or not the constitutions of the universe include electrons should be taken as physical or non-physical according to some form of metaphysical idealism. So even with the discovery of it, we don't actually know if they're real or not real, or physical or not physical, more like. And we're there. We know, looking back 50 years from now, we definitely know we're only in the truth statements right now, where there's nothing that will change.
That's right. My goodness. And so what is this point? Well, he says we no longer believe that the Thomsonian electrons exist. All features of Bohr electrons have been retained in current theory. It's legitimate to question as to whether or not there ever were any such things as Bohr electrons, given what we know about electrons today. And so he says, why did he take us through this mini crash course on the history of electrons? Well, because his key point, and here it is. Over time, as the science of a particular area moves on, it is often the case that older views of some entity are abandoned, and in light of current theory, scientists no longer believe that they were such a thing. Well, if that's the case, if science can be wrong, then how can it be the ultimate source of knowledge? That's the problem that he's pointing out here.
Right. We all believe in the electron, right? And we all believe that babies should not be tortured. Well, in 50 years and 100 years, which one of those two will still be around? Both of them? Neither of them? One or the other? That's the question. Well, the second reason for believing somewhat tentative about belief in electrons derives from the debate between realism and anti-realism in science. Very fun one if you're going to take your philosophy of science is this debate. Very roughly, a scientific realism holds that the entities that populate our successful theories, things like electrons and current views of matter and atom, are real, and that the theory descriptions of those entities are true, or at least approximately true.
And by contrast, he tells us in one way or another, the various versions of anti-realism claim that a successful theory is just that, merely successful. And so the success of a theory has, notice this, no implications whatsoever for the ontology or the reality of the unobservable entities under consideration, right? So just because it's successful doesn't mean that the things that they are positing as being in existence are true, right? And so thus, even though electron theory is successful, that does not mean that electrons actually exist, and as evidence of their view, anti-realist, he tells us, cite several theories in the history of science that were successful for a long time, but that we now believe were false, right? So this is, I think it's sometimes called the pessimistic meta-induction. Objection to realism is what this is sometimes called in the literature, right? So you look at, these various successful theories and, you say, all you really want is a successful theory. Doesn't matter whether or not it's true. In fact, many theories that we thought were successful in the past turned out not to be the case. And therefore, we don't need truth with regard to theories. All we need is success. Right. That's all scientists should be looking for.
I mean, the biggest realization was when we were in physics 2, and we, as a collective class, gasped when we realized that Newtonian mechanics was false and didn't work anymore. But we just paid really good money to learn how wrong we were. And so that's always fun to teach physics and then kind of blow the little ones' minds a little bit by them.
You could have learned it at on the back of a bubblegum wrapper.
Listen, I'm going to save you $15,000. You won't believe me, but your kids will enjoy this. So, yeah. Well, for Moreland, it doesn't seem to him to matter whether or not is a realist or an anti-realist for the point that he's trying to make. The point is this. It's important for the lay community to know that, 1, that there is this realist, anti-realist debate, 2, that the intelligent advocates on both sides, and 3, even if one opts for realism, the mere presence of sophisticated versions of anti-realism would seem to require a realist to temper his or her certainty about the reality of the entities. They're strong head charge, and then here comes the anti-realist to say, hold on, is it true or does it just work? And then they go, skirt, 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 maybe. Well, I'm pretty sure. I'm 99% sure, not quite 100%.
Yeah. All right. And so he says, for these two reasons, then, the history of theory abandonment, replacement, and change in science. So that's one, right? We abandon theories, we replace them, they're changed. And the presence of robust versions of anti-realism, right? The reality claims of science are often, though perhaps he tells us not always, much less certain than the public and especially the advocates of scientism realize. So there, the point he's making here is these claims to truth may or may are less certain than the scientism folk are really realized because of these two, at least these two issues, the history of theory of replacement and abandonment, and the presence of robust versions of anti-realism. But he says, by contrast, the case for God and for certain ethical claims, right, torturing babies for fun is immoral, is strong. Indeed, it is not foolish to think that our legitimate degree of rational warrant for believing in God and certain ethical claims is greater than what we have for many assertions of science, despite, he tells us, what scientism advocates claim.
Right. All right, well then, to summarize then, that we have seen first that the laws of logic and mathematics have greater rational certainty than the claims of science because the former are a priori, necessary truths, while the latter are a posteriori, or contingent truths. So science has to do a lot of experiments to maybe get to truth, but when you pull up your calculator on your phone, the numbers that are displayed there are of a greater certainty to you than all of the circuitry used to derive that expression because you're too lazy to learn your times tables again. So
that's right. Liars may figure, but figures don't lie. Right?
Well, second, we have seen that no matter what neurological advances and technologies are made in the future, we will always have greater epistemic authority for knowledge of our own conscious states than we can ever have of the laws of nature and science. And third, we've seen greater epistemic weight for self-evident moral claims than we have ever for the existence of something like even the electron, a thing that you had to draw a whole bunch of clouds around, and make sure that the protons equaled the neutrons and electrons had the same charge as the neutrons. I remember doing those. I wish I could just write, well, we don't even know these are real, and just be able to turn that in. And then I'd probably get kicked out into the philosophy department there. Well, all these things point individually, but especially collectively, and it shows that the claims of scientism, are simply false. The fact that
so these are non-sources or non-scientific sources of knowledge that we have that seem to be even superior than scientific claims. Right?
Yeah, exactly. All right. Well, that's it for the chapter. We're plugging right along with this book, and chapter 8 will be next time. And so hopefully you'll able to pick up the book and see the value that's there. Again, we haven't covered absolutely everything, and there's a lot more there to pull from. We're just covering some of our favorite points as well. And so all the links for the books are found in wherever you found this, and you can pick them up there in whatever fashion you'd like, ebook or physical copy. Just know that whatever you're holding, the electrons may or may not be there, and you'll find out maybe in 50 years. So
and
hopefully
you'll be called electrons.
That's right. I always tell the students that I teach, discover something, name it after yourself, and you'll force people hundreds of years from now to utter your name, even though they don't want to.
Even if it's wrong.
That's right. All right. So hopefully next time you'll join us next week. And so let's say thanks for joining us, and we'll see you next time.
We'll see you next time.